So we're doing grade 12 mathematics paper 1 November 2024 revision paper. So we're going to jump into question, I think it's question 10 now. We're in question 10, yeah. So in question 10, this question is very important, right? This is a question where you apply your calculus. So you'll be doing optimization of functions and rate of change. But in this particular question, you're going to learn about rate of change, calculate the calculus of motion. So it's very important that you understand this question, and it's very important that you understand the gist of this question and what they're really trying to teach you, so you can be able to answer all other questions. This question 10, it is definitely going to come in your exam. In your final exam, you're going to find this question. So please tune in and let's do this question together. Boom. So question 10 says a cyclist rode from town P and stopped at town T. Okay, so let's just try and visualize that. So let's say this is town P and stop at town T. Okay, and the speed is in kilometers per hour in which the cyclist rode is represented by the equation here. So the equation of a speed this is the equation that we have here. Great, so we're going to use that. And then they say, note, speed is the rate of change in distance with respect to time. So you need to know that speed is the rate of change with respect to time, right? It's a rate of change with respect to time, meaning, if I have to write that down for you, speed, let's call this speed, is definitely a rate of change with respect to basically, it's derivative with respect to time. It's a rate of change. It's a rate of change in distance with respect to time. Say S just represent distance. So meaning this is a derivative of the distance that we have. Okay. So let me know if you don't understand this part here. It's such a very important part to understand. And that's how you then represent this statement in mathematics formula. I mean, if you understand that, just type I don't understand or tell me I do understand. Thank you. Okay, so let's go to 10.1. So 10.1 says calculate the maximum speed that a cyclist reached on this ride. Okay, so maximum speed that a cyclist reached on this ride, meaning, so if we talk about maximum, we talk about the turning point. So this is the point where a cyclist was really speeding up. So the cyclist, meaning a cyclist, they come a point where it speed up, and then reach a maximum turning point and roll down and stop. So this maximum turning point, if you think about it, this is a point where the derivative of speed, meaning the second derivative of distance or the first derivative of speed, is equal to 0. That is the maximum turning point. So they're asking you calculate the maximum speed that the cyclist reached. So it is when the second derivative of a distance equal to 0 or the first derivative of a speed equation is equal to 0. Okay, so what you're going to do then, you're going to say, okay, great, so let's derive this. So derivative of this is going to be negative 3 times 2t, 2 minus 1, right? Plus 18 times 1 times t, 1 minus 1. Does it make sense? If this doesn't make sense, let me know. But it's part of your revision, meaning, let me give you some notes, just so make sure we're all on the same page. So if you have f of x is equal to ax squared, let's call it b. This is a derivative of this going to be a times b x b minus 1. That's what we're doing here, right? So this is going to be negative 6 t, 2 minus 1 is t plus 18, because t power 1 minus 1 is 0, t power 0 is just 1. And then we're saying then, okay, cool, the maximum speed is when this second derivative is equal to 0. So it's when this is equal to 0. So then you're just solving for t. So you have 6t is equal to 18, and you divide by 6 on both sides. So your t is equal to 18 divided by 6 is what? So if you punch that in your calculator, you should get, let me just think about it. 18 divided by 6 should be 3 times 6. This 3. Yeah, t is equal to 3. So your t is equal to 3. So this is equal to 3. Then you need to figure out what is your speed. So then you're going to take the 3 and substitute in this equation. So s of 3 derivative, the first derivative is going to be negative 3 times 3 squared plus 18 times 3. Make sense? So the speed when time is 3. So basically we're saying at time, when time is after 3 hours, right? That's when he reached the maximum speed. That's what we're saying. After 3 hours, that's when he will reach the maximum speed. Now we're trying to figure out, calculate that. What is that maximum speed, right? To calculate the maximum speed, you just take the time, which is 3 hours, substituting in our equation, this equation here, to find the speed. So it's going to be negative 3. Just punch it in your calculator, you should get 27. So if punch in your calculator, you should get 27. This is in terms of hours, this is in terms of kilometers. So at 27 kilometers, that's when he had the maximum speed at 27 kilometers. Okay, so let me know if you understand this part of the equation. They're always going to ask you about speed, the rate of change, and all of that. So if you understand this part, you're definitely going to understand other part of the equation they're going to be asking you. Okay, but I'm going to continue to 10.2, but make sure you ask if you don't understand. I'm here for you. So let's go for 10.2. Let me just wrap this off because I'm not going to need this. I might need the rest of these notes. But 10.2 says calculate the distance between point P and time T and time P, right? So of course we know that the cyclist started time P. So at time P, time was 0, okay? And then at time T, we don't know, right? We don't know after how many hours was the cyclist at time T. Okay, so the first thing is calculate the distance between P and T. Now, what you need to understand again is S prime T is a speed, right? Which is essentially a derivative of a distance. This is basically a derivative of a distance. And we can find an antiderivative of this distance. We just have to reverse the derivative, right? So if, let me make an example here. If this is how, if you remember, with my notes, if this is how you find a derivative, you can reverse this derivative. So if you have f of x, this is this called the g of x prime is equal to axb plus let's just axb, right? So the antiderivative of this will be basically a over b plus 1 x b plus 1. Does that make sense? That's how you find an antiderivative of this derivative here. Okay, you say a over b plus 1 x power b plus 1, and that's what you're going to be doing here. We need to find the antiderivative of this. So you're going to say this is going to be negative 3 over 3, of course, right? It's 2 plus 1 t 2 plus 1 plus 18 over, so remember it's 1 plus 1, so it's going to be 1 plus 1. Okay, and that's the derivative. And s of t, this is of course negative 3 over 3, that is negative 1, so it's going to be negative t. 2 plus 1 is 3, and 18 divided by 2, that is 9t. 1 plus 1 is 2. So this is the equation that represent this just the distance, not the speed. So now this is a distance representation equation. Make sense? Now we can able to find the distance between P and T. But to able to find that distance, we need to able to understand that it is, if you find a derivative, right? Remember, derivative is a turning point, right? We know that is a turning point. So what is the time when it arrives? So a turning point is when this is 0, meaning this is when it stopped, right? We know that at these 2 points, okay, if I have to say more words such that it makes sense, right? We know that at P time was 0, but at T we don't know what's the time, so we need to figure out what that time is. Okay, we know time was 0 there, but we don't know what the time is. But the way to find this both time is basically taking the derivative of this equal to 0 and so for T. So you're going to have negative 3t squared plus 18t is equal to 0. Of course, we know the other one is, the other t is 0. So you can just, this is just purely algebra. So you just factor out the common factor, which is t. So we're going to have minus 3t plus 18 is equal to 0. So you can see t is equal to 0 or minus 3t plus 18 is equal to 0. We already know this part here. We already know that t is equal to 0 at P. We know that. And then we have negative 3t is equal to negative 18 divided by negative 3 on both sides. So t is equal to what? 6. So we know now that it happened when t after 6 hours. So the cyclist drove for 6 hours between P and T. It drove for 6 hours. So if it drove for 6 hours, how long did it travel then? If it drove for 6 hours, calculate the distance between P and T. How long did it travel from P to T if it drove for 6 hours? So we're gonna just say take that 6 hours, right? Because we know that it drove for 6 hours. We're gonna just S of C, so minus C, 6 power 3 plus 9, 6 power 2, S of 6. So if punch that in your calculator, you should get 108. So it drove 108 kilometers. And ride, essentially, the cyclist rode for 6 hours and there was a 108 kilometer ride. And that's how you do your calculations. Oh my goodness, I use a different color, but it's fine. So basically, you see that how you get marks here. Basically, you need to get, of course, you get a mark for your answer, and you get your mark for getting this right, substituting 6. You need to get a mark for that, and you get a mark for getting this right as well, finding an antiderivative. So there's 3 marks, and then you get, of course, you're gonna get a mark for a 6, and get a mark for realizing that. So that's how you get your 5 marks. Please let me know if you don't understand this part of the equation. I know a lot of students are confused about how to do a rate of change, calculus of motions, velocity and acceleration, distance, and all of that, how they use calculus. You know what I mean? Please let me know. If you have more questions on this, let me know. I'll try to figure out to do more questions for you. But for now, this is how question 10 looks like for 2024. And I'm happy that we're doing it together. I'm happy you're here. Please share with your friends. If you find this video valuable, please tell me by just giving me a like, and I'll know that you find these videos that I'm doing for you valuable, and I'll continue doing the videos for you. But for the next video, I'll be just doing question 9. Okay, so I'm doing question 9, and this is very exciting. So I'll see you in the next video. Boom.